Hi, this is Becca, and this is TriTutoring's lesson on factoring. Anytime we're factoring, the first thing I want to look for is a GCF, the greatest common factor. This is something we could divide out of all the terms we're factoring. In this case, if I have x squared plus 10x plus 24, and really we think of it like there's a 1 in front of that x squared, then there's nothing helpful that I could divide out of all the terms. Of course, I could divide everything by 1, but it doesn't change what I'm factoring. So there is not a GCF here that I can divide out of all three terms. The good news is, because that coefficient in front is a 1, as I'm factoring into the pieces that multiply to make this trinomial, I know I already have these two factors, these two parentheses. I have an x with something times another x with something. That comes from my first term as the x squared. Now as I'm trying to fill in the rest of these factors, I want to ask myself, well, what multiplies to make 24? And if I add it together, I get 10. Things that multiply to make 24 is 1 and 24, 2 and 12, 3 and 4, 3 and 8, and 4 and 6. So which of these add up to make 10? Well, that's 4 and 6. Now I have to pick what symbols go with this as well. I'm going to use a plus 4 and a plus 6. I want them both to be positives because two positives multiply to make that positive 24, and positive 4, positive 6 is what makes 10. Now, if you have the time to do so, you can always go through and check your answer. To check the answer, we actually do the reverse of what we just did. So instead of starting with a trinomial, I use those factors and I multiply them through. I multiply x times x to get x squared. I get 6x, 4x, and 24. And if I combine like terms in the middle, this does give me that x squared plus 10x plus 24. That was my goal. So let's try another trinomial here. I have x squared plus 2x minus 15. I don't notice anything I can divide out of every term, but because we start with x squared, we know each factor is just going to start with an x and an x. Now to fill in those terms, I'm asking myself, what multiplies to make a negative 15, but when I add it together, I get 2. Things that multiply to make 15 are 1 and 15 and 3 and 5. Because it's a negative 15, I actually have two combinations for each of these. I could have a negative 1, positive 15, negative 3, positive 5, or positive 1, negative 15, positive 3, negative 5. So which of these combinations makes a positive 2? That's this negative 3, positive 5. Because I've already listed out those symbols, I already know which one's plus and minus, I have those factors totally filled in, and that's my final answer. On the next one, I have x squared minus 5x plus 4. Again, I don't see anything I can divide out of each of these terms, and I know that the factors are each going to start with an x and an x that came from that x squared. Now as I fill in the rest, I'm going to ask myself what multiplies to make 4, and when I add it together, I get negative 5. Well, my combinations to make 4 are 1 and 4 and 2 and 2. And I'm trying to multiply to make a positive 4. Well, neither of these combinations make negative 5, but I do notice 1 and 4 make 5. If I make them both negative, then I would get a negative 5 there. And negative 1 times negative 4 does make a positive 4. So my factors are actually that negative 1 and negative 4. You can use two negatives to multiply to make a positive. On this last one, we have 2x squared plus 7x minus 15. So when I have a coefficient in front of the x squared, I would really like for it to be a GCF. I'd like to say, hey, I could just divide everything by 2 and then take that 2 out front. That way it makes it like the simpler questions we've started with, where there's just an x squared to split apart. However, because we have this 7x and the 15, it is not ideal here for me to try and take that 2 out front, because then I'd end up with those fraction terms. Instead, what we have is a 2x squared that's going to split into the factors. Well, if I'm splitting the 2x squared into my factors, then I know it comes from 2x and x. Think about that check. Think about if you multiplied here and we went through into that double distribute, we'd end up with 2x times x, which would be 2x squared. So in order to get that coefficient in front, we have to have it in one of those factors. This does change how we're filling in the terms. And one of the fastest methods here to find the factors is to use guess and check. So I still want to ask myself what multiplies to make negative 15. And we've listed those factors out already once before. It's 1 and 15 and it's 3 and 5, but we don't necessarily know which one's positive and which one's negative yet. Now, as I fill in these terms, notice that none of them give me a 7. Right? 1 minus 15, 5 minus 3, 3 minus 5, none of those are making 7. Here's why. When we fill in these options as our factors, one of the terms is getting doubled. Notice this term on the far right of my factor is getting multiplied by 2. So if I were to check these, and I checked just for this one, negative 1 and 15, I have 30x minus 1x. Together that makes 29x. So for this method, it is best use a pencil and fill it in to see which of these works. Obviously negative 1 and 15 didn't work, or at least didn't work in that order. So I could switch their places. Still, negative 1 and 15 in this case makes negative 2x plus 15x, which is not 7. As I'm kind of thinking about what makes sense, I don't really want to use a 15 again because I feel like that's going to be multiplied by a 2, or just in general, it seems like too big of a number. So I'm going to try and use this next combination, which is negative 3 and 5. And if I do 2x times 5, I get 10x. Negative 3 times x is negative 3x, and together that does make 7x. So this is the correct combination in the correct order to make my factors here, using that guess and check method. So this was a quick overview of some factoring, showing how to factor those trinomials with the x squared term in front, thinking about that GCF, and also when I need to split that term in front with the coefficient and maybe use guess and check method. Thanks for listening today, and we'll talk to you next time.